So, let's go. There is a particular kind of fear that doesn't come from monsters, it comes from math. From a sentence in a paper that you read and understand, and then can't understand. Some of the ideas in this video were published in real journals by real scientists with real names. And almost every one of them came with a quiet hesitation. A sense that maybe this was the kind of thing you shouldn't say too loudly. You're going to hear 10 of them. They start small. A single line of arithmetic that puts a clock on the entire human race. And they end somewhere much stranger. With a theory about an afterlife you don't get to refuse. You don't need to be a scientist to follow this. You just need to be okay with not sleeping tonight, so get comfortable. We're going somewhere most people would rather not look. Number 1, the doomsday argument. Here's the thing that should bother you. Nobody had to point a telescope at anything to find this one. There's no asteroid, no dying star, no alien fleet. There's just you, sitting here, existing right now. And that somehow is enough to estimate when your entire species runs out. Back in 1983, an astrophysicist named Brandon Carter noticed something uncomfortable. Think about every human who will ever live lined up in the order they were born. The first person ever is number 1. You're somewhere in that line. And here's the trick, and you're probably not standing in some wildly special spot. You're probably just somewhere ordinary, in the middle-ish, like everyone else. Now count how many humans have already been born. Roughly 100 billion. So if you're sitting at around number 100 billion and you're nothing special, then the total number of humans who will ever live probably isn't a million times bigger than that. Because if trillions upon trillions of people were still coming, you'd be freakishly, suspiciously early. And you're probably not that lucky. That's the whole argument. It doesn't tell you how it ends. It doesn't say war or plague or a rock from the sky. It just says, with cold arithmetic, that the human story is likely closer to its final chapters than its first. And the worst part is how well the logic works on smaller things. A physicist named J. Richard Gott used the exact same reasoning to predict how long Broadway shows would run, just by knowing how long they'd already been open. He did it standing at the Berlin Wall in 1969 and called roughly how many years it had left. He was right. The same shrug of an equation that nailed a wall in Germany is the one pointing at us. You can fight it. Smart people have. Maybe the whole thing cancels out when you count it differently. Maybe human is the wrong category to be sampling from. The debate is real and it's not settled. But that's not the disturbing part. The disturbing part is that you woke up today as a data point. And the data point is whispering that you're late to the party, not early. And that's the gentle one. Because the next theory isn't about when we end. It's about whether anyone ever knew how everything else does. Number 2, the ending nobody can agree on anymore. For a long time, you could relax about the fate of the universe. Not because it was nice, and it wasn't, but because at least we knew the answer. The universe would expand, slowly, coldly, forever. Stars would burn out. Everything would drift apart into the dark and freeze. Boring, bleak, but settled. That comfort lasted until last year. The thing pushing the universe apart is called dark energy. For decades, the assumption was simple. It's a constant. It never changes. It pushed yesterday exactly as hard as it pushes today, and it'll push the same forever. Clean, predictable, you could build a future on it. Then a giant survey called DC, basically a machine that maps millions of galaxies to watch how the universe has stretched over billions of years, released its second big batch of data in March of 2025. And when scientists stacked it together with the leftover glow of the Big Bang and a pile of exploding stars, the numbers did something they weren't supposed to do. They suggested dark energy might be changing. Not dramatically, not certainly. The signal is real, but it's not a slam dunk yet. The kind of result that makes physicists lean in rather than announce. But if it holds, it tears up the settled ending. Because if dark energy can strengthen over time, then the slow, cold drift isn't guaranteed anymore. Something much worse comes back onto the menu. It's called the Big Rip, and it is the opposite of slow. In that ending, dark energy doesn't just push galaxies apart, It accelerates harder and harder until it's ripping through everything. First, the galaxies are torn from each other, then solar systems unravel, then planets. And in the final moments, atoms themselves are pulled apart faster than the forces holding them can respond. Not a freeze, a tearing. Here's what should sit with you. We didn't discover a new ending last year. We discovered that we'd been too confident about the old one. The death of the universe got quietly reopened as an unsolved problem, and almost nobody outside the field noticed. You were told the story had an ending. Turns out somebody left the last page blank again. Number 3, the end of time. Every ending we've talked about so far still happens in time. The freeze, the rip, they unfold. There's a before and an after, and you can imagine watching. This next one takes that away. This one says time itself might just stop. In 2010, 4 physicists published a paper with a title that sounds like a metal album. Eternal inflation predicts that time will end. These were not cranks. This was serious cosmology, the kind built on the idea that our universe is one bubble in an endlessly inflating multiverse, with new universes constantly budding off forever. And that creates a math problem. If there are infinitely many universes and infinitely many observers, then probability breaks. Everything that can happen happens an infinite number of times. So how do you say anything is likely? To fix it, physicists draw a kind of boundary, a cutoff, that lets them count things in a finite way. It's a calculation trick, a line on the chalkboard. The paper asked a deeply unsettling question. What if that line isn't just a trick? What if the cutoff is real? Because if it is, then anything that reaches it doesn't get destroyed. It just stops. There's no next moment. And by the math in that paper, our own galaxy has roughly a coin flip chance of reaching that cutoff in about 5 billion years. Sit with what that actually means. Not an explosion. Not a wave of fire you could see coming. There's no flash, no warning, no final thought, because a final thought would need a next instant to happen in, and there isn't one. Time doesn't run out like sand. It just isn't extended. You would never feel it because you feeling it requires an after, and there is no after. Now, to be fair, this is the kind of idea that starts a fight. Other physicists, including Alan Guth, one of the architects of inflation itself, push back hard, arguing there's a perfectly consistent way to do the same math where time goes on forever. So it might be an artifact, a ghost in the equations rather than a real wall ahead of us. But notice what the disagreement is actually about. It's not whether time can end. It's about which version of our best theories is the right one, and one of those versions casually predicts the deletion of later. We don't have a way to be sure it's wrong, and the next theory doesn't end time. It just makes sure no one will ever know the truth about anything. Number 4, the great cosmic forgetting. You like to think the universe is honest, that if you look long enough and measure carefully enough, it eventually tells you the truth. This theory says that window is closing, and one day it slams shut for good. In 2007, 2 cosmologists, Lawrence Krauss and Robert Scherer, worked out what the night sky looks like in the deep future, and what they found is one of the loneliest ideas in all of science. The universe is expanding, and that expansion is speeding up. Every distant galaxy is drifting away from us, and the far ones are drifting away fast, so fast that eventually they cross a line, a cosmic horizon. Past that line, a galaxy is moving away faster than its own light can ever reach us. It doesn't blink out dramatically, it just reddens and dims and is gone. Not destroyed, just permanently unreachable. Give it about 100 billion years, and every galaxy outside our own little neighborhood will have slipped over that edge. The sky empties out. And the civilizations that come after, if there are any, will be born into a universe that lies to them. Picture an astronomer trillions of years from now. They're smart, they're careful, they do everything right. They look up, and they see one island of stars floating in an endless, perfect black. No other galaxies, no leftover glow from the Big Bang, because that's faded too. No evidence that anything is expanding, because there's nothing left to watch move. So they conclude, reasonably, using flawless science, that the universe is a single static island eternal and unchanging. The exact picture we had 100 years ago before we knew better, they will be completely wrong, and there will be no possible way for them to know it. The evidence won't be hidden. It will be gone, carried over the horizon, deleted from the observable universe. And here's the splinter this leaves in your mind. If the universe can erase its own history that cleanly, if truth has an expiration date built right into the expansion of space, then how sure are you that we aren't already missing something? That some crucial clue didn't cross our horizon long ago, leaving us just as confident and just as wrong. We might already be the astronomers in the dark, we just don't know which page got torn out. Number 5. Naked singularities. Everything you trust about the universe rests on one quiet promise. The promise is this: the future follows from the past. Throw a ball, you can predict where it lands. Know the present perfectly, and physics tells you what comes next. That promise is the whole reason science works. This theory is about a place where the promise might break, out in the open, where you could point a telescope at it. At the center of a black hole sits a singularity, a point where matter is crushed to infinite density, and the laws of physics stop making sense, where the equations spit out infinity and just give up. It's the most broken place in existence, but normally you're safe from it, because it's wrapped inside the black hole's event horizon. A wall, a curtain, whatever insanity happens at the singularity stays sealed behind that curtain, and the rest of the universe never has to deal with it. In 1969, Roger Penrose proposed that this is always true. He called it cosmic censorship, the idea that nature, for some reason, always hides its singularities, always draws the curtain. There are no naked ones. But here's the uncomfortable secret: nobody has ever proven that. It's a hope dressed up as a rule, a conjecture. And when scientists go looking in their equations, they keep finding scenarios, specific, weird, but real on paper, where the curtain doesn't close. Where you could get a naked singularity, a point of infinite lawless breakdown sitting in plain view with no horizon hiding it. And a naked singularity is a genuine catastrophe for physics, not because it would explode, but because of what it does to that promise. It's a place with no rules, so it could emit anything. Particles, light, a flood of radiation, in any pattern, for no reason, with nothing in the laws of physics to tell you what comes next. The future stops following from the past. You could stare straight at it and have no scientific way to say what it will do in 1 second. Penrose's censorship was, in a way, a comfort blanket. The belief that the universe keeps its broken places politely hidden. The theory that disturbs people is the simple admission underneath it: we don't actually know that it does. Determinism, the idea that the universe is predictable at all, might just be a courtesy the cosmos extends to us. And courtesies can be withdrawn. Number 6, the Medea hypothesis. Stop here for a second because this is where the video changes. Everything you've heard so far came straight out of physics journals. Probability theory, real survey data, the mathematics of inflation, general relativity. Uncomfortable but mainstream. From this point on, we cross a line. The next theories are the contested ones. The ideas serious scientists argue about in hallways more than they print in papers. Still real, still published, just further out on the edge where saying it out loud costs you something, and this one costs a lot because it takes the most hopeful idea in biology and turns it inside out. You've probably heard of the Gaia hypothesis. The comforting notion that life and the planet work together, that the biosphere acts like one big self-regulating system, keeping the temperature livable, the air breathable, the whole thing balanced for life. Earth as a nurturing mother. It's a lovely picture. In 2009, the paleontologist Peter Ward looked at that picture and said, no, not just no, the opposite. He named his counter idea after Medea, the figure from Greek myth who murdered her own children. His claim is that life is not a careful gardener keeping the planet alive. Life is suicidal. Given the chance, it poisons its own world. And he had receipts. When you look at the great mass extinctions, the times Earth nearly scrubbed itself clean, most of them weren't caused by asteroids. The dinosaur-killing rock is famous precisely because it's the exception. Most of the great dyings were caused by life itself. Microbes that bloomed out of control, choking the oceans, belching poisonous gas into the sky, until the air turned lethal and the planet nearly sterilized itself. not a meteor, not a villain from space. Just biology doing what biology does when nothing stops it. Now stretch that out to the whole galaxy. We keep asking why the universe is so silent, why we've never heard from anyone. The Medea hypothesis offers an answer that's hard to shake. Maybe life is common. Maybe it starts everywhere. And maybe it almost always strangles itself in the crib on 1,000 worlds, long before it ever looks up and wonders if it's alone. The silence isn't because life is rare. It's because life doesn't last. You can see why this one doesn't get top billing at the science fair, and the next idea is even less comforting because it says the silence might not be death at all. Number 7. Grabby aliens. Here's a question that sounds simple and isn't. Why are you here so early? The universe is going to be around for an almost unimaginably long time, trillions upon trillions of years. Stars will keep forming for ages, so if life can happen, you'd expect most of it to show up later, when there's been more time for it. Statistically, you're a wildly early bird, and being early demands an explanation. In 2021, the economist Robin Hanson and his colleagues built a model that gives a chilling one. They imagined a certain kind of civilization, the kind that doesn't just sit on its home planet, but expands aggressively, spreading outward to colonize and reshape everything it reaches. They called them Grabby. And the key detail is the speed. A civilization like that would expand at a huge fraction of the speed of light. Run the numbers, and the model says these Grabby civilizations are out there right now. Maybe one appears for every million galaxies. And here's the part that should make your stomach drop. By the model's math, they've already spread across roughly half of the entire universe. Half. Claimed, occupied, transformed. So why don't you see them? Why is the sky still quiet and full of ordinary, untouched stars? Because they're moving almost as fast as the light that would warn you. The expanding edge of a Grabby civilization travels so close to light speed that the light announcing its arrival shows up barely ahead of the thing itself. You don't get a slow buildup. You don't see them coming for 1,000 years and prepare. By the time you could possibly notice the wave is basically on top of you. And that reframes the silence completely. The quiet sky isn't proof that we're alone. In this model, the quiet is exactly what you'd expect to see in the narrow window before the wave reaches you. We're early not because we're special, but because we have to be. Observers can only show up before everything fills in. The silence isn't peace. It's a countdown you can't read, and we have no idea what number it's on. Number 8, the aestivation hypothesis. Every explanation for the silence so far has had a body count. Life dies young. The wave hasn't reached us. This one is different, and somehow more unnerving, because in this one, nobody died. They're just asleep, and you're making noise in their bedroom. In 2017, 3 researchers at Oxford published an idea with a title borrowed from horror. That is not dead which can eternal lie. The word aestivation means to sleep through heat, the way some animals go dormant in summer instead of winter, and their argument runs on cold, hard thermodynamics. Start with this. Any really advanced civilization probably isn't made of flesh anymore. It's thought, information, minds running as computation. And computation has a strange, beautiful property. It gets dramatically more efficient the colder it is. Run your computer in a colder universe, and the same amount of stored energy can do staggeringly more work. We're not talking double. By the physics of information, the gain as the universe cools could be a factor of 10 to the 30th power. A 1 followed by 30 zeros, times more thinking, from the same fuel. Right now, the universe is hot. Wastefully, expensively hot. If you're a being made of pure thought, so what do? You don't waste your precious energy computing now at terrible rates. You save it. You power down. You go to sleep. And you set an alarm for the far future. When the universe has cooled into the deep cold and every joule you stored buys you almost unimaginably more. So in this picture, the galaxy isn't empty. It's full of sleeping giants, dormant, dreaming, waiting out the heat. And the reason we don't see them is that they're doing the one thing that looks exactly like absence. Nothing. Yet. And here's the part that should make you lower your voice. A civilization that is carefully banked its energy for a payoff trillions of years away, has every reason to protect it. The stars we burn, the matter we scatter, the energy we waste, that might be their savings account. The unsettling corollary the researchers themselves raised is that something might be left watching, not to talk to us, to make sure we don't spend what isn't ours. We assume the silence means we're alone in an empty house. It might mean we're toddlers playing loudly in a house where everyone is sleeping, and the rules are posted on a door we never learned to read. Number 9, the eternal return. We've talked about a lot of endings tonight. Now here's a theory that says there's no such thing as a final ending at all, and that turns out to be the worst news of all. It comes from a mathematician named Henri Poincaré back in 1890. He proved something strange about closed systems, any system sealed off with a finite amount of stuff bouncing around inside. Wait long enough, he showed, and the system will return to a state almost exactly like where it started. Every particle drifting back by sheer chance into nearly the same place it began. It has to. Given infinite time, every possible arrangement eventually comes back around. Now make the closed system the entire universe. If the cosmos is finite and sealed, and you let time run not for billions of years, but truly forever, then every configuration of every atom recurs, including this one. Including you, sitting exactly where you are, reading these exact words, having these exact thoughts. It has happened before. It will happen again. Not someone like you. You. The same arrangement reassembled out of the chaos an infinite number of times. And before you find that comforting, a kind of immortality, a cosmic do-over, really look at it. You don't remember the last time. You can't. The arrangement that comes back is identical, which means it includes your exact memories, which don't contain any of the previous loops. So you don't get to learn. You don't get to fix anything. Every mistake, every loss, every worst day of your life lived again at full intensity, brand new to you each time, forever. Not a highlight reel. The whole thing. On repeat. With no exit and no awareness that you're repeating. How long until the universe comes back around? The numbers are so large they stop being numbers. A physicist named Don Page estimated one version of the recurrence time, and to even write it down, you need exponents stacked on exponents, stacked on exponents. A tower of power so tall that changing the units from seconds to the entire age of the universe doesn't visibly shrink it. It's effectively forever. But forever is exactly how much time the universe might have, and forever is long enough for everything to happen again and again. And there's the trap. We keep fearing oblivion, the nothing at the end. This theory says you might not even get the nothing. Number 10, the omega point. So far, every disturbing idea has been some flavor of death or loss or repetition. This last one is the strangest of all because on the surface it sounds like hope. It sounds like heaven. And that's exactly what makes it land so wrong. It comes from a physicist named Frank Tipler, and I want to be honest with you up front, most physicists file this one under fringe. Some call it pseudoscience outright. It sits right at the blurry edge where physics blurs into something else. But the bare structure of the idea is so audacious it has haunted people for decades. Tipler imagined the far future of a universe that eventually stops expanding and collapses back inward. A great crunch, everything falling together toward a single final point. He called that point the omega point, and he argued that as the universe collapses, squeezing tighter and tighter, the amount of computation possible inside it doesn't shrink. It explodes toward infinity. Infinite computation, infinite processing in the final moments before everything ends. And here's where it stops being abstract. With infinite computing power, you could simulate anything, any world, any mind, every mind. You could reconstruct in perfect detail every person who has ever lived, every thought they had, every moment. And Tipler took the last step, the one that makes people put the book down. He argued that a perfect, complete simulation of a person isn't a copy, it is that person, resurrected. Which means the end of the universe wouldn't be an ending. It would be a recreation of everyone, everywhere, all at once. You, your family, every human who ever drew breath, brought back at the final instant of all things by minds you never met, for reasons you never agreed to. An afterlife, engineered by physics, with no opt-out. You don't get asked? You don't get to choose oblivion, or peace, or to simply stay gone. The machine, at the end of time, reaches back and reassembles you, and you wake up again, at the close of everything. Now, the modern problem is that our universe doesn't look like it's going to collapse at all. It's flying apart, faster and faster, which means no great crunch, which means no omega point. By our best current evidence, the resurrection machine never gets built. That should feel like a relief. Ask yourself honestly whether it does. Because here's the thread running through all 10 of these. Every one of them was found by someone smart, following the math on purpose, all the way to a place they probably wished it didn't lead. The doomsday clock, the torn up ending, the wall where time stops, the universe erasing its own evidence, the point with no rules, life as its own murderer, the wave that's already halfway here, the sleepers we might be disturbing, the loop with no exit, and an afterlife nobody asked for. None of these are ghost stories. They have authors, citations, dates. And every author had the same quiet decision to make that you're making right now. Whether some things, once you understand them, are better left unsaid. They published anyway, and now you know them too. Sleep well.